All right, so now we're going to show you how to graph your data. Now, in order to graph your data, you simply need x variables and a y variable, right? So in our lab, we have to think back and remember which one is our x or independent variable. And if you remember, we changed the incline. We wanted to see how the incline, which we measured with sine of theta, affects the acceleration. So average acceleration is our y variable. Sine of theta is our x. For the purpose of helping you remember, I'm going to delete that title and I'm going to just type x and I'm going to type y above both those columns just so that we don't forget. Okay. And you'll notice these two columns. This one right here is the uncertainty of our x variable, which is sine of theta. And this one over here is the uncertainty of our y variable, which is the average acceleration. A good processed data table should really just have this bit of information. This is really all I need in order to make any graph. I need to know all my x coordinates and their corresponding y coordinates. I need to know the uncertainty in all my x coordinates and the uncertainty in all my y coordinates. And this is what I'm going to use to graph. Everything else was just used just to create this data table right here. So, in order to graph, I need to highlight my x variables, my x coordinates, and I need to highlight my y coordinates. The only problem is you'll notice when I tried to do that, the x variables stopped highlighting. So I'm going to try that again. Highlight my x, and if I hold down Shift and try and highlight my y coordinates, you'll notice it highlights everything in between. So don't do that. You need to highlight your x. Now hold down Control, the Control button, and highlight your y variables. Now holding down Control means select, whatever you had selected, keep that selected, and then select the other ones too. So now that I have those highlighted, both my x and my y coordinates, I need to insert my chart. So I go to Insert, and I look for charts. So here's charts, and I want to make a scatter graph or scatter plot. So I will click on this, and I want one without connecting the dots. Remember, connecting the dots makes it sound like your data is exact. So we want one without connecting the dots. Do not connect the dots. All right, so here is my data, all graphed and ready to go. Now I just need to edit this graph so that it has my labels and all the other stuff I need. Just a warning, let me show you a couple things that might happen if you do your highlighting and selecting it wrong. Just a quick note, okay? If you only accidentally have one data set highlighted and you graph that, okay? One of the ways you can tell it's wrong is by looking at the x-axis. Notice the x-axis says 1, 2, 3, 4, 5. And all the dots are right on whole numbers. That's not normal, okay? My x variables are not 1, 2, 3, 4, and 5. Look, this is 0.02. This is 0.04. My x variables are not 1, 2, and 3, right? So what it's doing is if you only give it one string of data, it will just graph the first point at 1, and then it'll graph the only set of data you have as the y coordinate. So this is a good way to always check it's a good note to always check your graph and make sure you truly graphed it right. The graph you see represents the information you put. Also another way, right, if I click off the graph and then watch when I click back on, watch what happens to this column right here. When I click on the graph, it highlighted this information, which tells me this is the information it's graphing. Notice it's not highlighting my y column. So something's wrong. I'll delete that graph, I'll remake it. Let me show you another quick and easy way to tell if you screwed something up. Oops, let me do that again. If I graph it now, scatter, right? Notice I have two different colors. And the reason is, let's find out if I click on the graph. The reason is, oh, it didn't highlight my data. But the reason is because I have two different trends. I have sine of theta and I have average acceleration. So it's doing the same thing we saw last time, but it's doing one graph for both. And it often does this if you highlight two different sized columns. So it did it because I highlighted this whole column, including the title, and I highlighted just the numbers. Okay, it'll do that. So make sure you highlight just your numbers, and then you can go to Insert, Chart, and if there's one color and the data looks like it matches, you're good. Now that we have a data that works, we need to make sure we insert things like axis labels and chart title and things like that. There are several different ways to do it. You can try and find a design that you like and put it in. I never do that because I don't really like their different designs and it's never the way I like it. So I'm going to show you how to do it bit by bit. You go to Layout under Chart Tools. Now notice, if you're clicking anywhere else, you will not see a Layouts tab. Okay? You have to click on the chart first, then the Charts tool will appear and you'll have these three new tabs: Format, Layout, and Design. So click on the graph, go to Layout, then go and click on Chart Title, and let's insert a title. So I'm going to do above the chart, axis titles. Those are the titles for your X and Y axis. We need those. Primary horizontal axis, yep, I need one. Let's see here, primary vertical axis, I need one of those. I'm going to do rotated, that's my favorite. Now that I have the titles in, they just say chart and axis title. The thing about the new Excel 2007 and Excel 2010, is that you insert the things first and then you change them to what you want it to be. Okay, so we just insert random titles and then we can change them to what we want. So let me change my axis titles. Let's hear X variable. My X variable was sine of my angle, right? So I'm going to type in sine of theta. If you want, you can also even insert the symbol by clicking on the Insert tab, Symbol, and then you just find theta somewhere in here under Greek. Actually, it's right there. I'll double click and it'll insert it in. Okay? Or you can just type out theta if you don't want to get fancy. All right, now normally I put in units, but sine of theta has no units, so I'll just leave it. All right, and then I'm going to highlight my y-axis, and I'm going to, I'm going to change that to average acceleration, and I can abbreviate too if I want, and I make sure I put in my units. Please make sure your titles are clear. Don't just put acceleration, it's the average acceleration. And don't forget your units. Every single title needs units unless in the random situation where it has none, like sine of theta. Then I'm going to give it a title, give it something very descriptive to what it is. For example, I'm going to call this an average acceleration versus sine of theta graph. That's the name of my graph. Okay? And it tells me exactly what the graph is all about. All right, now the next thing we're going to do then is we've got our titles in, right? We've got a graph. You can do other things with layout. If you like grid lines, I often like grid lines, you can put in your horizontal and vertical grid lines, right? I'm going to show major and minor just for make it a little bit interesting, and I kind of like those grid lines on there. All right, so now that I have my chart all formatted the way I want, I need to add in my uncertainty. So you'll remember I have here, I click on my data and then it highlights this. I've used my X variables, I've used my Y, but I need to use now my uncertainty. So we're going to put the uncertainty on here, and we do that by having bars. And for example, this first one is 0.2. Your acceleration is about 0.2, and then its uncertainty though is about 0.01. So we're going to draw a little bar that goes up about 0.01 or 0.016, and then goes down about 0.016, and that will show the range at which it's uncertain. And Excel will do this for you. You just got to click on your chart, and they're called error bars. So you go again to under Chart Tools, you go to Layout tab, and it's under error bars. So we're going to click this button and we're just going to, again, insert any old random error bars. It doesn't matter which one you put in. It really doesn't, because it'll just insert random error bars. So I usually do standard, it doesn't matter. It'll just insert these random error bars that mean nothing, and then you're going to change them to the correct size. Okay? Do not leave the error bars like this. I can tell. All right, so then what we're going to do is let's edit our error bars for the x-axis. That means the horizontal axis, right? So I'm going to right-click on any of the horizontal error bars. So I'm just going to grab it, right-click, and I'm going to go to Format Error Bars. And again, if you need to pause the video at any time, please do so and do this yourself. So I'm going to go to Format Error Bars. And now I have these options. I'm going to leave it on both directions, both because this represents both the plus and the minus, right? These values here. And I have several options. I can do a fixed value and just put in a number, right? Some giant number if that's my error bar, or the size of my error. But you'll notice the size of error isn't always the same, so I can't do that. I could put in a fixed percentage if all the percent uncertainties are all the same, but they're not all the same percent uncertainty. The other thing I can do, and which you will end up doing the most often, is you can do a custom, and then you can tell it which values to do for each individual error bar. So I'm going to do custom. I'm going to click on specify value. This little thing pops up right here, and I'm going to click on this button right here which says, hey, where in your data table are your error bar values? So if I click on this, it acts like it's waiting for me to do something, and I'm going to come over here and I'm going to highlight the information that is my error in horizontal your horizontal axis, which is this data right here. I'll hit enter. Okay, and notice these are the positive error values, but I also need the negative ones. Remember, these are the plus and the minus for the horizontal direction. So I need to enter them for my negative values as well. Enter. So I did it for plus and minus. I'll hit OK. And you'll notice that they all just resized to their proper lengths. Now, which one was smallest? They're all around the same, but let's see here. Which one was smallest? This first one is smallest. And you'll notice you look at it and it's just ever so slightly smaller than all the other ones. Okay, so this is a good way to do get your error bars in. You just randomly insert it, then you fix it. We got to fix the vertical ones now, and it's going to be your y-axis, error in y. So I will right-click, format error bars. I'm going to do custom values, specify values. I'll select this column for my positive. I'll select it also for my negative. I'll hit enter, OK, and look, they're all the right size now. Notice they are really small. So let me try and make it bigger to see if we can actually see them. Okay, you'll notice that the biggest uncertainty is this one right here, the very first one. Apparently there was a lot of error in that first one. And you'll notice that this very first one, the vertical one, is the biggest. All the other ones are still pretty small. Now when you print this graph, you'll want to print it on an entire page, one page for the whole graph, because sometimes these error bars are hard to see and you want it blown up as much as possible. Another thing to keep in mind is that if ever your error bars are so small that you can't really see them because the dot kind of takes up the space, then always please make sure you just write a quick little note on it. You can always just do insert and like add a text box or something and just say note error bars, or vertical, I was going to say vertical error bars are there. They are just really small. What that does is, as your grader, it kind of flags me to double check to see if truly your error bars are small and it makes sense that they may not show up on your graph. So that way you're not knocked for not having your vertical error bars, and you're welcome to do that at any time. Alright, so I'm going to shrink this graph again. This is just too big to deal with, and then we're going to continue because there's one more thing that you need to be able to do on your graph before we're all said and done, and that is to be able to insert a trend line. That is the best fit line that describes your data. If your data looks like it's a linear relationship, which this looks like it's a linear relationship, what you're going to do is you're going to click on your chart and go to Layout one more time, and under Layout is the option of Trend Line. And we're going to click Add Trend Line. And I want you to always choose More. Never choose any of these. Even if you think it's linear, don't choose linear. Just select More, okay? And from here, we're going to, oh, dang it, I lost my option. If you ever do this, you need to edit it. So right-click on the trend line, Format Trend Line, and it appears again. And I think it's linear, so I'm just going to leave it as linear, but you always need to go more options so that you can check this checkbox, which is Display Equation on Chart. And the beauty of Excel is that it will calculate the equation for your trend line, and so now you know your relationship. So now that I have that, I'm going to close, and I'm going to do one more thing now that this graph is calculated. I'm going to change my y variable in this equation that they gave me to what it actually is. Y is too generic. Your y variable in this lab is average acceleration. So I'm going to at least put an A there for acceleration, or I could type out average acceleration if I wanted. But we usually just use variables, right? So I'm going to put A for acceleration. This one here is sine of theta. So I will type in sine of, and again I'm going to just be nitpicky and make it look good. So insert theta in there. And now I have an equation that in terms of my actual variables, and this is the equation for my graph. You cannot make a conclusion without this equation. This equation is the entire point of your lab. This is what we're here to find, is the equation that models the relationship between your sine of your angle and your average acceleration. And with that, we have finally just completed graphing our data.